everyone, and welcome to this video going over Lesson 6.1, Proofs about line segments and angles. In this video, we are going to be warming up to write our very first geometric proof. And so in order to write a good proof, first of all, you need to know your definitions of your vocabulary words. Some of our vocabulary words up until this point have been right angle, midpoint, bisector, complementary, supplementary. And so make sure you brush up on those definitions so that when they are mentioned in a proof, you know what they are and what conclusions we can make because of them. We also need to know our postulates and theorems. Up until this point, there are two main postulates that we have talked about, and those are the segment addition postulate and the angle addition postulate. The segment addition postulate states that if we have a segment with two endpoints and a point in between them, that AB plus BC should equal AC. Those pieces of the segment added together should equal the length of the entire segment. Similarly, we also have the angle addition postulate that says that the measure of angle ABD plus the measure of angle DBC should equal the measure of the entire angle ABC. So once again, those pieces added together should equal the measure of the entire angle. And so those are the only two postulates we know up until now, but we will make a list because as we go through this next chapter, we are definitely going to be introduced to more postulates and theorems. And the last requirement for writing a good proof is knowing basic rules of logic. In order to make a good proof, you need to know what goes in a logical order, and we need to go step by step and make sure that we justify every statement that we are making. And so let's practice justifying statements about segments and angles. In A, it says that if angle ABE is a right angle, then the measure of angle ABE is 90 degrees. Why do we know that? Why do we know that if ABE is a right angle, then it measures 90 degrees? Well, that's the definition of a right angle. That is knowing one of your definitions. Because ABE is a right angle, then it must equal 90 degrees. And so for your justification, all you have to say is that that's the definition of a right angle. Next, it says the measure of angle 2 So the measure of angle 2 plus the measure of angle ABE, make sure that you fix that typo for me. So plus the measure of angle ABE, right there, equals the measure of angle DBE, which is the entire thing. Why is that true? Well, we just said that that was our angle addition postulate. Two smaller angles added together will equal the entire angle measure of what they make up. So that is the angle addition postulate. Next, given B is the midpoint of segment AC, prove that AB is congruent. Remember, this is the congruent symbol, which means the same measure or the same length. So given B is the midpoint of AC, so point B is right here. Given point B is the midpoint of AC, that must mean that AB is congruent to BC. Why do we know that? Well, we know that's what a midpoint does. A midpoint is in the middle of a segment and it creates two congruent segments. And so that's the definition of a midpoint. In D, it says if angle 1 is supplementary to angle FBG, then the measure of angle 1 plus the measure of angle FBG is 180 degrees. Why is that true? Well, you might be thinking, because it said supplementary. And if it's that easy of an explanation, just using the word that it said, that means we're using that definition. You're right, because it mentions that the angles are supplementary, they add up to 180 degrees, that's using the definition of supplementary. In E, it says that EB, so EB is right here, EB plus BG equals EG. So that's saying the length of EB plus the length of BG equals the length of the entire thing, which is EG. We said above that that was our segment addition postulate. Whenever you see just 2 points together, that's referring to the length of a segment. I've had a lot of questions on how we know if something's a segment or an angle. If it's an angle, you'll see this angle symbol, the alligator. But if it's a segment, you'll just see 2 points right next to each other. And so this is the segment addition postulate. The lengths of the pieces of the segment added together equal the length of the entire segment. In F, it says if angle 5 is congruent to angle 6. So if angle 5 is congruent to angle 6, then BF bisects angle EBC. Remember, bisects means a ray that cuts an angle in half, creating 2 congruent angles. So if we know that angles 5 and 6 are congruent, that must mean that BF bisects angle EBC, because that's what it means to bisect an angle. That's the definition of bisects. And lastly, if the measure of angle 1 plus the measure of angle 6 is 90 degrees, then angle 1 is complementary to angle 6. We know that that's true because that's the definition of complementary. If 2 angles add up to 90 degrees, then they are known as complementary. And so, when we start to write geometric proofs in the next video, these are some examples of justifications you can make for some statements that you will make in your proof. Chances are, if you use one of your vocabulary words, your justification will be the definition of that vocabulary word. For example, if an angle is a right angle, then we know that it measures 90 degrees because that's the definition of a right angle. And so hopefully you can brush up on those postulates and vocabulary words, and so that you are able to write in those justifications for our 2-column proofs. Please let me know if you have any questions, and I will see you in class.